This is section 7.5, part 2, graphing inequalities and shading them on a two-dimensional graph. Primarily what we're doing right now is we're going to determine dotted lines versus solid and whether we shade above or below. Once again, as a review, if it's greater than, we shade above the graph. If it's less than, we shade below the graph. So here we look at our first equation. Y is greater than 1/2 x minus 3. We're going to start at the y-intercept, which is on the y-axis at -3. So I'm going to put a dot there. Then realize my slope is 1 over 2. So I'm going to go up 1 over 2. Up 1, up 1 over 2, up 1 over 2, up 1 over 2, being careful that we're doing it correctly, obviously. Then we go the reverse direction, and we have it there. I now have to determine whether or not my line needs to be solid or dotted. Well, because it's not equal to, and it's just greater than, it's going to be a dotted line. So I'm going to make a dotted line. An ID card works really well for this. Please use a straight edge of some sort. So there's my dotted line representing I'm going to come up to my line but not include it for the shaded section. Now I have to say, where am I going to shade? Am I going to shade above the graph or below the graph? Well, it's greater than, so I shade above. So I'm going to take some kind of a straight edge just as a boundary, and I'm going to shade everything above the line. What does that mean? All of the answers up here are part of our solution. Any point up here, if you were to plug it in, for example this point 4, 2, if I plugged it into the equation, it would give a true answer. Now let's move over here to the right and let's look at this second illustration. Y is less than or equal to -3/4 x plus 1. I'm going to rewrite this with the negative in the top. A lot of times it's confusing with a negative sign that we forget it should always be going with the top number. So we're going to start this problem at +1. That is our starting point. From +1 I'm going to go down 3, and now I'm going to go over. Remember, always run to the right. So 1, 2, 3, 4. Let's do that again. Down 3, over 4. Let's go backwards in the other direction, up 3 and back 4, and do that twice. Since it's an equal to, it's not a dotted line in this case. And so now we're going to draw a solid line through our points. So we use a straight edge once again and draw a solid line through our points. Don't forget, put arrows on your graph because there's more off the graph than there is on it. Now, do we shade above or below? That's the question. Well, it's less than, so now we're going to shade below. So I'm going to take my straight edge and I'm going to shade everything below the line. So all of these points down here are part of our solution set. There's an infinite number of points. Let's now look down at problem 4 at the bottom of the page where I have a special case scenario. We have the equation y is greater than +2. Well, as a review, when it's y equals a number, the graph goes through the y-axis. So we go up to 2, and we're going to draw a line through the y-axis. Why did I make it a solid line? Because it's equal to. So that's why it's a solid line. Now it's greater than. This is easy to tell above or below. Above the line is greater than, so we shade everything that's above the line. Our last problem is x is less than -3. Well, let's do a little review again. X equals a number that goes through the x-axis. Well, let's go through the x-axis, but on the other one where we had a solid line, here, because it's not equal to, we're going to have a dotted line. So take your pen and go to -3 and draw a dotted line up and down at -3. Put your arrows on it. And now here's the one exception where we're not shading above or below. Now we go back to our number line ideas, because you can't be above or below a vertical line. So less than now shades to the left. So we go back to our number line and you shade in the direction that the inequality points. And so we've shaded everything to the left of the number line. This concludes our lesson over section 7.5, Graphing Linear Inequalities.